Okay, this is page 85 in your packet. Okay, so you have a function e to the negative 2x squared. They want you to find the first four non-zero terms. Okay, so now there are a couple series that you need to be familiar with. So e to the x was one of them. So the idea is now that you know e to the x, I can use this function to come up with e to the negative 2x squared. I don't have to go through and find all the derivatives anymore. So one of the functions series that you do have to memorize is e to the x, which is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot. Your general term is x to the n over n factorial. Okay, so you will have to know that, but this part is going to be really easy. So how do I create e to the negative 2x squared? So instead of taking all the derivatives, if you know this, all this is saying is wherever you see an x, just replace it with negative 2x squared. So the first four terms of this are 1, that stays 1, plus make this negative 2x squared, plus replace this with negative 2x squared, and I don't simplify anything right now. This becomes negative 2x squared, dot dot dot, and when I write my general term, just replace the x with negative 2x squared to the n over n factorial plus dot dot dot. So there's your first four non-zero terms and your general term. Okay, part B. Find the interval of convergence. I have my general term. It's not geometric. I'm going to use the ratio test. So let's do my setup. So negative 2x squared to the n plus 1 over n plus 1 factorial times n factorial over negative 2x squared to the n. Okay, let's simplify a couple things before we start taking the limit. This and this will leave me with an n plus 1. One of the negative 2x squares, the negative 2x squared to the n will drop out. So when you just simplify it before taking the limit, you should end up with over n plus 1. When I plug in infinity for n, this limit is 0. This is my ratio test. This limit is always 0, regardless of what x is. 0 is always less than 1. So my interval of convergence is all values of x or negative infinity to infinity. Okay? And then lastly, let g be the function given by the sum of the first four non-zero terms. Okay. Show that f of x minus g of x. So g is basically just the first four terms. So basically it's your polynomial. What happens when you take the entire series and subtract the polynomial? That's your error. They want you to show them that your error is less than 0.02, and they want to, when they write in this notation, they're really giving you what your x value is. So they're telling you that x is 0.6. Okay? So how do we find the error bound? And again, this is going to be an alternating series that converges, so we're just going to take the next term over. So I use the first four terms here, so think about what your next term looks like. So your next term is going to be negative 2x squared to the fourth over 4 factorial. So you just grab the next term. So basically when they don't use the words Lagrange error bound, Taylor's theorem, that's your clue that it is an alternating series error, which just means you grab the next term, and let's just plug in what we know. Let's see. Negative 2 to the fourth will give me a 16. My x is 0.6. This is really to the 8th power. And this is a scientific calculator problem. And if you punch this out, you get that. And this is just your check. Do you get to a number less than 0.02? Yes.